Bam. A lot of times we'll use z to denote a complex number. So z could be something like 8 plus 7i. Its conjugate, z bar, or 8 plus 7i bar, when you take its conjugate, all you're doing is you're changing the sign on the complex part. So that would be 8 minus 7i. It's kind of a neat thing that happens when you multiply a number times its conjugate. So z times z bar. Well, let's just do it out and find out. This is going to be 8 plus 7i times 8 plus 7i. This is when you FOIL. Now be careful on the test. There's going to be a couple problems where I'll ask you to add or subtract complex numbers. Those are supposed to be easy. So it's when you have to multiply them that it gets a little bit more complicated. 64 plus, oops, you know, I made a mistake here, didn't I? What's my mistake? The mistake is that the conjugate should have a negative there. Oops, my bad. So 64 minus 56i plus 56i. And finally, what's the last term going to give me? Minus 49i squared. I'm glad to hear that you both gave me I squared, because without that I squared, you're going to get this one wrong. The nice thing for us here is that we're going to get some cancellation. Both of those cancel each other out. And what happens here? Minus 49i squared becomes plus 49i. So overall, 113. Beautiful. If you're paying attention on the videos, one of the things I showed you was that you can do this on a graphing calculator. And I have no problem with you checking your answer. I still want to see the work that I just showed. But just as a quick reminder, I can do this, 7 plus second button, and then well, that gives me my I. I really needed an 8i, so let me just put the 8 back in there. 7 plus 8i, and then 7 minus 8i. Yeah, Dimitri?
You need to switch the 7 and the 8.
Oh, I got them backwards? That's all right. Thank you. So, 113. Still get the same thing, but you're right. I did have the 7 and 8 reversed. A little dyslexia this morning. That's okay. But it's cool that you can check these on your graphing calculator. It's really nice. And I encourage you to check it, get these answers right, know you got it right before you hand it in the exam. All right. Let's apply that. Certainly one of the harder problems that you would run into in this set of homework would be something like this. 12 plus 3i divided by 1 minus 5i. So you'd be asked to simplify this. For whatever reason, mathematicians don't like square roots in the denominators. I could give you some reasons historically, but let's just actually knock off this problem. This actually has a square root in the denominator in the guise of I is the square root of negative 1. We don't like to divide by complex numbers like this. So I want to make that a real number in the denominator. And I can do that if I multiply both the numerator and denominator by the conjugate. What's the conjugate here?
1 minus 5.
Yeah. So 1 plus 5i over 1 plus 5i. In the denominator, you're going to get 26. Woohoo! All right, but let's FOIL that out. 1 plus 5i minus 5i minus 25i squared. In the numerator, first term, 12. Outside term, 60i plus 3i plus 15i squared. And I'm sorry, I'm running out of room there. The cool thing is that the denominator is going to experience a lot of nice simplification. The 5i's are going to cancel, and I'll be left with 1 plus 25. In the numerator, again, I'm going to get some simplification. It's going to be 12 plus 63i. What happens to plus 15i squared? How can I simplify that? Minus 15. Now, I'd appreciate if you combine like terms here. I get a little unhappy when people leave it like this. So let's go a little bit farther. That's going to be minus 3 plus 63i over 26. And that's fine for me. In WebAssign, they might want you to write it as negative 3 over 26 plus 63 over 26 times I. That separates it into a real and imaginary part, because the real and imaginary parts have lots of different applications in various branches of physics. So, cool. Leave it there. That one look okay, Kira? All right. Looking good? Good. All right. Ava, good on that one? Cool. Let's finish up with one last little topic here. It might be a little bit new to you, so let's spend some time with powers of I. And in particular, we're going to look at several different powers of I. We're going to look at I to the 32nd power, I to the 34th power, I to the 33rd power, and I to the 35th power. So lots of different powers of I. And let's just see what happens. Now, in simplifying powers of I, there's one power of I that I expect you to know fully and completely. Does anyone remember what it is? I squared is negative 1. That's what's going to get all our work done here for us. And let's see how. We'll start out by writing this as I squared to some power. But what number am I going to have to put on the outside of the parentheses so that it's going to equal 32? Yeah, so basically it's what times 2 gives me 32, or 32 divided by 2 gives me, and thank you, 16. Okay, let's use what we know. We know that I squared is negative 1. Okay, so we got negative 1 to an even power. What's negative 1 to an even power? It's 1. So if you have negative 1 to an even power, you get 1. Negative 1 to an odd power, you get negative 1. It's just that friendly. So let's take a look at what difference it's going to make if we go up to I to the 34th power. Again, you want to start out by writing this using some power of I squared. So Sarah, in this case, what would it be? I squared to the what power? 17. Excellent. And Riley, what can I put in here instead of I squared? Negative 1. Negative 1 to an odd power is negative 1. Beautiful. Now that works well and good until we get down to here. Unfortunately, we've got an odd number here, which is kind of a pain. But let's work around it this way. I'm going to write this as I to the 32nd times I. Why can I do that? When you multiply things with the same base, you add their exponent. And even though it's not written, it's understood that there's a 1 here. The rest of this is the same as before. You could write this as I squared raised to the 16th times I. That I is just going to hang along for the ride the rest of the way. I'm not going to do anything with it, but you can't just get rid of it. That becomes negative 1 to the 16th times I, which is 1 times I, or better yet, just I. Finally, this is going to be I to the 34th times I. And we kind of know what happens here. I to the 34th became negative 1. So, I don't know. I'll do it all out nonetheless. 17 times I, negative 1 to the 17th times I, or negative 1 times I. Now, there's nothing wrong with doing these things and checking them on your calculator. Your calculator can help you out. Make sure you got the right answer. I'm not going to give you credit for knowing how to use your calculator. I want you to know the math. But if you did check it, I to the, which one do you want to do? Let's do 35. I to the 35th power, great. But here's what I could do. I could give you something a little different. And it still works the same way. I to the, let's do 842 power. It's still exactly the same thing. I'll start out by writing it as I squared. To what power, though? What power am I going to use? 421. Which is negative 1 to the 421 power. That's negative 1. But sometimes, and maybe I should have chosen like 843, sometimes your calculator doesn't work on these. Let's just try this one. And if this one doesn't work, if this one works, we'll try to the 843rd power. Raised to the 842. Yeah, it didn't exactly give you what you expected, did it? So you can't completely rely on this. Now, if you did parse through this enough, take a little time to understand what's going on here, you'd see that it's not as crazy of an answer as you expected, but that would take a little bit more time in explaining, and I want to get you back on your homework. So, are you looking okay with powers of I and complex numbers? All right, excellent. Go for it.